Okay, we're going to roll.
Okay, so here's for both cameras, sync reference. Great, thanks so much for taking the time. Could you just start off by introducing yourself and telling us what your role is at the moment?
I'm Professor Sir Dave King, and currently I am the Executive Chairman of the Centre for Climate Repair at Cambridge, which I founded, and I'm also Chair of the Climate Crisis Advisory Group, which is an international group, 16 members from 12 countries dealing with the crisis of climate change.
Just a little bit about your care and your relationship with the environment. Why did you accept the position of Chief Science Advisor? What motivated you?
The main reason I accepted it, I was here at Cambridge as head of the chemistry department. I had a very big research group, 25, 30 people, and was doing really excellent work. The only reason I really took it was because I thought I might have an influence on the policy on climate change. And that's how it transpired. I formed a very good relationship very quickly with Tony Blair. And within a few years, the government was leading globally on actions on climate change.
Round about 2000, what were your thoughts at that point about where we were and where we were heading?
I had been very worried for the previous 5 to 10 years about the way things were developing. We had the first UNFCCC, the first United Nations meeting on climate change in 1992. And we made very, very little progress over the following 10 years. And at the same time, this was a crisis of imaginable proportions. If we had operated then I believe we would today not be in the climate crisis we're in, and today we have simply run out of time.
Okay. So climate repair is a response to that?
Climate Repair, the centre was set up in response to that. I left government in 2017 when I had been leading on climate negotiations in the run-up to 2015, and maybe I could just say the British effort was globally leading. I had 165 climate attaches in embassies around the world that I'd built up with Tony Blair. And I used those climate attaches. Every ambassador, British ambassador, knew this was our prime target to get action globally on climate change. And I don't believe that we would have got that agreement in 2015 without the British effort. We also put a very big sum of money into helping the negotiations. When I tell people that sum amounted to £9 billion spent over 10 years, you will see that this was a very big effort. I made 96 official country visits in the run-up to COP21 in Paris, because I believed negotiations bilaterally with countries were much more important than the big bilateral meeting with 190 plus countries trying to reach agreement.
So within repair, just talking about the mission, in particular, if you could just talk, expand, reduce, remove and refreeze.
So let me take you to the topic of tipping points. Tipping points have been in the scientific literature for some time. The global leader on this has been Tim Lenton, who is now at the University of Exeter. And Tim Lenton set out a list which amounts to about 15 tipping points last week in Science. A critically important paper on the tipping points was published, saying that temperatures between 1.5 and 2 degrees is when many of the major tipping points would tip. Now, here's a critical point. The Arctic Circle region has been heating up for the past 20 years at roughly 4 times the rate of the average for the whole planet, which means that today the Arctic Circle is at 3 degrees above the pre-industrial level, and therefore the Arctic Circle tipping points have now irreversibly tipped without interventions. Now what does this mean? And I think it's important that I spell this out. What happens in the Arctic Circle impinges on the entire world and is already doing that. The extreme weather events we're experiencing around the world today across from the North American continent to Europe, to Asia, the extreme, and Australia, etc., the extreme weather events are heavily driven by what's happening in the Arctic Circle region. So as the Arctic ice has been lost over the Arctic Ocean during the 3 polar summer months, when the sun has moved up to the North Pole, we now find the Arctic Circle region is warming up at this incredibly fast rate. And the net result is that Greenland, sitting in the Arctic blue sea now during those 3 summer months, is losing its ice irreversibly. And when all of it is gone, 6.5 meters to 7 meters sea level rise. And also, now this is important, permafrost on the land mass around the Arctic Ocean, the North Pole being roughly in the middle of the Arctic Ocean, permafrost is now losing methane explosively, particularly in Siberia, northern Siberia. What we are seeing is a disaster in the making. If all of that methane was emitted, let's say over a 20-year period, global temperatures will rise by 5 to 8 degrees centigrade. And when would that happen? It has already begun to happen on a smaller scale. My fear and our fear is that in a few years' time, because this heating of the Arctic Circle region is still continuing, this may release rather quickly. So what we are looking at, and the extreme weather events arise from the fact that there's a jet stream that blows around the Arctic Circle region in an anti-clockwise direction, roughly circular. That jet stream is totally distorted now during the 3 polar months because the North Pole region is now warm air above the Arctic Ocean. And that warm air pushes the cold air down. So for example, last year Texas saw minus 16 degrees centigrade, snow and so on in Texas, unheard of before. And at the same time, in the same year, we saw the western coast of America, all the way up to Canada, experiencing temperatures of an extreme kind. When I say extreme, 5 to 10 degrees centigrade hotter than ever observed before. And this little town, Lytton in British Columbia, is a symbol of this. Very upper middle class town, 135 lives lost, because if you have no access to air conditioning and you're trying to live through a heat wave at 50 degrees centigrade, you're not going to survive for more than 3 or 4 days. You can't get rid of your excess heat. So even in this well-to-do town, a significant number of fatalities. What is now happening in Pakistan, the flooding there, and the extraordinary heat waves being experienced in India, there's no doubt the thousands of people dying in Pakistan today from those floods, unheard of floods, and the number of people that will die from heat stress in India, northern India particularly, could well be in the millions. So we're looking at a crisis evolving while I'm talking to you. This isn't something waiting for us in the future. The way in which we think we should handle this is to find means of refreezing the Arctic Ocean so that we can buy time. The Arctic Ocean is covered with ice during the polar winter when the sun has moved down to the South Pole. And what this means is that there is a thin layer of ice formed during that winter period. It disappears very quickly when the sun returns for the 3 polar summer months up in the North Pole. But if we can retain that layer of ice and let it grow every winter, then we've got a chance. So what we're looking at is how can we put white cloud cover over the entire Arctic Ocean for those 3 summer months. This piece of work is being stimulated by us here in Cambridge, and we're progressing it relatively slowly and carefully. We don't want to see negative effects of putting white cloud cover over there. We need to take the Arctic Circle people with us, and I'm already working on that. And for example, the former president of Iceland, longest serving President Grimson, has approved of what we're doing. The requirement is urgent, And we would like to be seeing this happening in 5 to 7 years' time. It would be good if I could state that it would happen in a shorter period of time. If we can achieve that, we're buying time so that we can do the first of our 3 R's. The last is this refreeze. The first is reduce emissions deeply, rapidly, and with justice to all people. But every ton of greenhouse gas we emit from today will have to be removed together with all the excess greenhouse gases we've put up there already. We are currently at well over 500 parts per million if we count in not just carbon dioxide, 420, but also methane. The pre-industrial level was 270 parts per million. So we have already closed in on doubling the amount of greenhouse gases. That only causes rising temperatures, changes in weather patterns and so on. We cannot foresee a manageable future for humanity without deep and rapid emissions reduction and greenhouse gas removal at scale. I believe we need to reduce from 500, 550 parts per million to roughly 350 parts per million to achieve a manageable future for humanity. So we've got a coherent, logical, rational program. We're not pretending that Cambridge can solve all of this. The Centre for Climate Repair at Cambridge is a hub, and we're setting up consortia for different programs of work, bringing in global experts to back us up.
So I'm just going to, can we just stop a second? I just want to change files.
Yeah, absolutely.
Cool, okay. Sync there. So in talking about removal, which would tie in with Peter Fikowski's work that he's doing or trying to stimulate as far as what they refer to as climate restoration. What are your thoughts on that and the challenges around that?
I could tell you one of the biggest challenges is that greenhouse gas removal at scale should not be seen as an excuse to let the oil, gas and coal industry continue to pollute the planet. If we continue putting 50 billion tons a year up there, we are cooked, frankly. That's end game for humanity. And not only humanity, for the biological systems of the world and our ecosystems. What I do want to stress, therefore, is greenhouse gas removal at scale, meaning I believe we've got to aim to remove 30 to 40 billion tons of greenhouse gases a year going forward in time, and that would still take us to the end of the century to achieve the 350 parts per million. A lot of hard work, and we have to keep refreezing the Arctic to give ourselves that time. And at the same time, while we're doing that, we have to insist on deep and rapid emissions reduction.
So one of the, actually let me just move on to somewhere else. Really the science has always been here. We've generally ignored it. We've always known how to deal with stuff. So it's more of a behavioral challenge that the planet faces rather than a scientific one. I mean, scientifically you're trying to solve the mess that we've left behind. But most of it's more attitudinally and politically and just expanding from that. My wife published a paper recently that scientists wanting into action. The information's there, but ultimately it gets diluted in deal making and so forth. How do we get around this?
There's no question we're not going to manage this if the developed countries don't understand the crisis we're in and how we have to lead the way. Excuse me. How we have to lead the way into close to zero carbon dioxide emissions, close to zero methane emissions. We can do that. And I have to say that here in Britain, we are one of those nations that are doing quite well. Our industrial revolution began here, all fed by coal. We're now effectively no longer burning coal to make electricity. And in that process, we have significantly reduced our emissions. We're closing in on 50% reduction compared with 1990. So we are delivering to a certain extent. We could be doing it much more quickly. And I'm afraid that the response to the Russian-Ukraine war, for example, is leading to exactly the opposite of the right behavior. We're seeing energy prices go up. That's the driver we wanted when we said, let's put a carbon price on using fossil fuels. Now we've got a very high price on on fossil fuels, and this is the opportunity for us to switch across to renewables much more quickly, to electric vehicles, etc. The whole program ought to be accelerated. The last thing we should do is try to recover more oil and gas from fracking, from North Sea oil, etc., oil and gas. Any new venture of that kind is not going to put anything into the marketplace for 5 to 10 years. You're not dealing with the Russia-Ukraine crisis when you do that. But let me then go to the developing world. I believe China is leading the way in many ways. They have developed more photovoltaic industries in China. They're putting up more photovoltaic for electricity production than anywhere else in the world. They're putting up more wind turbines and certainly much more nuclear power stations. So China is doing what it can. But if your economy is growing at 6 to 8% a year, and you're taking a lot of people out of poverty in that process, and they've been amazingly successful at this, then you still need more and more electricity going forward. And they have been very dependent on coal. I'm pleased to tell you that this year, coal consumption in China has actually reduced as they promised. So I think going forward in time, China is somewhat of a leader. India would like to be in that position, but India is so heavily dependent on coal. Now we in the West, we in the wealthy countries, need to help these countries make that transition. We promised back in 2009 an annual budget of $100 billion a year to help the developing countries make this transition. That budget, public money, has never exceeded $21 billion a year. We have failed in that, and that failure leads to mistrust between the developing and the developed world. And that's where we are today. I think the responsibility should be on the 80% of the GDP production in the world coming from 25 countries. Those 25 countries can lead the way forward. I managed to set up a program called Mission Innovation on the first day of COP21 in Paris. And Mission Innovation is a program aimed at public spending research and development money into new technologies in the post-fossil fuel world. That is a program that was expected to yield $30 billion a year. With Trump in the United States, he withdrew American funding. Now Biden has replaced that. And we're spending $25 billion a year with 25 countries, representing 80% of global GDP. It's possible, as I realized in the run-up to Paris, to create a smaller group of nations who can make key decisions. The COP process with 197 nations needing unanimity is extraordinarily slow. So we need faster routes to manage this problem.
So like a Security Council, as it were, a kind of a...
Yes, I have even written to the UN Secretary General to suggest a Security Council for managing climate change. But that in itself is quite challenging, because when you say like a Security Council, I would like to see representatives of indigenous people taking those decisions, not just the developed countries, which is essentially what the Security Council is today. How do you select representative countries but creating a smaller number? But I come back to the question you've asked. What is the big pushback? And we all know the United States could have taken a leadership position on this back in '92 and we wouldn't be in this problem, right? And so today, with Biden clearly having a big battle, but he's making progress, today there is still an opportunity for the United States to take leadership. What has held the United States back over that time? I was in those negotiations with Tony Blair, and I can tell you quite simply the fossil fuel lobby. The power of the fossil fuel lobby and a few extremely wealthy people creating a lobby system that would frankly be illegal in most democratic countries that operates very openly. It's like your gun lobby, and there are many other lobbies in the United States, which seems to us to run counter to the notion of democracy. So I think if you take a poll of the people of the United States, despite all the counter stuff in the papers and media and so on climate change in the United States, if you take a poll of the United States people, then you find people want action on climate change. So I think it is the power of wealth that we're looking at. And then we have another situation. What happened in Brazil with Bolsonaro's election, what has happened very, very recently, even in Sweden, with their biggest party in their latest elections being an extremely right-wing party, completely against immigration, but also against action on climate change. So what we see is a notion of populism spreading around the world, and that in itself is heading towards a situation where people cope with the challenges that we've been talking about by forming barriers between their country and other countries in the world. Now that is a dystopian future. A utopian future, of course, is that we all pull together and manage the situation.
I'm going to ask something that's kind of repeating much of what you've said, but I just want to use this as a separate soundbite. But the Paris Accord and the Inflation Reduction Act that just came through, a lot of people in the general public think, okay, so we're fine, but we're not. And if we just follow those two things, things aren't going to be okay.
You're quite right. We can't rely on the public media's responses, for example, to COP26 and so on around the world. The problem is solved is the message. However, extreme weather events around the world are pushing in exactly the opposite direction. And what we are finding is that there's a much greater reception to the idea, for example, of climate repair now than there was, let's say, 5 or 10 years ago. So I think the notion of what people are prepared to accept is changing quite dramatically. Europe is, I think, in this respect, quite a bit ahead of the United States still, but certainly young people, I would say progressive people right across the board, are in a much stronger position today than they have been before.
In terms of as far as climate restoration is concerned, which overlaps obviously with what you're talking about with climate repair, there's 4 areas that the Foundation for Climate Restoration are involved in: synthetic limestone manufacturing, seaweed permaculture, ocean iron fertilization, and acceleration of natural methane oxidation. And they kind of look at those as being, I guess, magnified natural processes that happen anyway. But the things that seem to be against them, if you overlook the notion of giving fossil fuel industry a free pass, the obstacles seem to be around scale and rollout. Can you share some thoughts on that?
In our case, what we have done is to examine every possible way of removing greenhouse gases at scale, and by at scale, we immediately eliminated any process where you could only deliver 1 billion tons a year. Right, so we were looking at 1 billion tons as our turn-on point when we started examining things in more detail. So I certainly think that there's no harm in doing these smaller enterprises, but what we want is game-changing enterprises. And so looking at the possibility of what we have is two big programs, and one of them is called marine biomass regeneration. And marine biomass regeneration is what it says on the label. We believe that we have a way forward of returning the biological population of our deep oceans back to where it was 400 years ago. And what happened in our analysis 400 years ago was that we began to kill the baleen whales. The baleen whales being the whales that have a lot of blubber, and they have a lot of blubber because they spend a large amount of their time deep under the surface of the ocean, 300 to 500 meters down, where they feed on krill. And when the whales have done with their feeding and used up the oxygen in their lungs, they come up to the surface. And if you get a pod of whales, say blue whales, the biggest of all, coming to the surface, what they do, because any mammal 300 meters below sea level, your orifices are jammed shut by the high pressure of the water. So when they come up, they breathe out the carbon dioxide, we can all see that happening, and they breathe in oxygen, and we've been aware of that for years, but we've only recently understood they also defecate. So when they come up, they create a very large area in the surface of the ocean of fertile whale poo. And the result of this is really quite remarkable, because if you do this over, let's say, 1,000 square kilometers, which would be fairly typical, within 3-4 days you've got a whole green area of phytoplankton. Phytoplankton is the initial foodstuff for fish larvae of every kind of fish in the ocean. The fish larvae all die because there's not much phytoplankton in the surface of the ocean, except where you create one of these green areas, and there they basically survive. And when you look at the same area 2 months later, you might have half a billion fish in that area. Now, if you imagine creating artificial whale poo, and our artificial whale poo will be obtained from natural processes. For example, volcanic dust contains all of the right ingredients, such as nitrates, silicates, phosphates, and iron, to mimic the missing nutrients in the ocean. If you can do that artificially, spreading it on the surface of the ocean, you will create large green areas of phytoplankton. Now, I do believe that if we can run this program forward for maybe 30, 40 years, we can see a repopulation of not only fish, not only crustaceans. Krill is part of the population that massively increases by the process, but also whales and other mammals. And so the result of this would be, if we can raise the whale population back to where it was before we began whaling, which was 400 years ago, we being the United States and Europe, then we could possibly build the population back up, and then they will perform this biological pump action that was so crucial to the biological systems of the ocean. Now, in that process, you're creating not only the forest represented by the green plankton, but you're also creating a forest in terms of the living matter in the oceans, equivalent to the wood that the tropical forests create, where carbon is sequestered. So in the living species that you're creating, a vast amount of carbon is trapped. Whales, when they die, drop to the bottom of the deep ocean, and all of that carbon is sequestered for a very, very long time into the future. So what we're looking at is a process that could possibly take up a minimum of 3 billion tons a year and possibly 12 billion tons a year of greenhouse gases. And we're spending a very significant amount of our time on that program.
How receptive are policymakers to the ideas that you're putting forward?
the notion of marine biomass regeneration, which deals with the issue of biodiversity in the oceans, is proving to be a very, very acceptable notion. And you can see that we are really describing the uptake of carbon dioxide in the process as a byproduct of returning the oceans to their former state. Now, of course, you will also note that increasing the ocean, the deep ocean fish population, is going to mean there's more fish for humans as well. And so, needless to say, it's likely that our work will extend to the small island states that have suffered from loss of fisheries over the last 20, 30 years in particular, that if we work around those states, we return their economy to roughly where it was before. Tonga, for example, historically exported the tuna catch basically to the United States. But their tuna catch is massively down at where it used to be, and their economy is subsequently suffering badly.
Okay, I just want to stop and start again. We're almost there. Thanks for your time.
Yeah, and I have to be off quite soon.
Okay. Just stop and start. Yeah. Okay. Great, thanks. So just a thought on this. So it's unfortunate that it seems that what creates kind of repairs sustainability in part is whether the idea is financially profitable.
Yes, and so if I take that as the cue for talking about marine biomass regeneration, our program will become quite expensive once we start operating at scale, for example, around the island states. And for that work, we will set up a not-for-profit company, and the not-for-profit company will work with people in the island states. We have to be invited to work with them, and we'll work in their extended economic zone, which is a large zone around each of the islands. And any funding that they offer us as a part of their increased profit will simply go into maintaining the not-for-profit company so that we can move on to other island states. When we do that, we will be working with islanders so we can leave them to continue the process we've developed, and it becomes part of a development strategy. Now, I want it to be known that we are not in this for the money to be made. It's very, very clear that there will be entrepreneurs moving in because of the increased fish catch, also because of carbon pricing. There is, in the potential of this process, there is no equivalent process that is so cheap at capturing a ton of carbon dioxide than marine biomass regeneration.
I've got two short questions from Peter Fakowski. If in 2050 we collectively failed to restore CO2 levels, what would the most likely reason be? Would the main barrier be technical, economic, or political?
I think Peter misses the point. The survival of the countries of the world to 2050 is unlikely to continue in anything like the pathway it's been in over the last 100 years, unless we can buy time by refreezing the Arctic. So I think the important thing is refreezing the Arctic. I'm not saying that takes a priority over removal. I'm not saying it takes a priority over reduction. But I am saying that buys time so that we can get to 2050 without a total disruption of our current economic system, our food system. Let me give you one example. We're now estimating that by 2030, the 90% of the land mass of Vietnam will be under seawater at least once a year. And when the land mass of Vietnam is flooded by seawater, that will mean the end of the third biggest rice-producing paddy fields in the world, the third biggest. So Vietnam is a very big supplier of rice into the world market. But it's not only Vietnam. Vietnam is all very close to sea level. The Mekong brought all of that silt down to create the whole of the country of Vietnam, and that's why it's a country majorly at risk. We know what's happening in Bangladesh. We know now what's happening in Pakistan. This is today. So I'm saying the crisis is with us today, and unless we can manage a way forward, we are not going to reach 2050 in a state in which we can take our planet forward in a manageable way for humanity.
Second to last question. I mean, you live and breathe this work that you're talking about. Where are you personally with this? What keeps you awake at night, or what allows you to sleep?
I simply cannot afford to be pessimistic on this. In my period working in the British government with Tony Blair, Gordon Brown, subsequently David Cameron, and with Theresa May, so I've worked with governments of all colours, we managed, and we're the only country to have done this, to get through a climate change committee of Parliament that sets a legally binding target for the government to reduce its emissions. And that is set on a 2-yearly basis, but it runs forward to at the moment, 2037. So we know our trajectory going forward, but that is a very positive story to tell you. But after the Russia-Ukraine war, our Prime Minister, our current Prime Minister, has announced we're going to allow fracking to happen in this country, and we're going to seek North Sea oil and gas, more North Sea oil and gas. Completely the wrong response as we're going forward. So there's no way in which my optimism developed by working in Britain allows me to rest back. I will continue working until I'm laid out in a coffin to see that we can create a manageable future. Let me give you a personal thing. I have several grandchildren now, the youngest of whom, Lola, is 2.5 years old. If you just ask the question, when she is at the end of this century and she is approaching 80 years old, will she be able to talk about her grandchildren and their future? And that really concerns me. I think that we are not only looking at the present generation, we're looking at intergenerational disaster management. Yeah, we're not doing that. We're not risk managing the future for future generations.
Peters, he had another question here, but I didn't want to ask it straight away. If we succeed in restoring CO2 and methane in 2050 and a sustainable population in maybe 2100, what opportunities might humanity have then?
So a sustainable population by 2100 is only going to come about through a series of major disasters. I'm afraid that Peter's population dynamics doesn't take account of the way population has developed. Yes, China had a one-child per family policy which was rigorously retained right across the country, and it has taken about 50 years for this population to stabilize, let alone to decrease. So what we can see is that kind of, if you like, draconian response in China provides a pathway forward, but it is not the response that most democratic countries can come forward with, and even that doesn't deliver the, 2 billion that might be thought of as a safe population for the planet. I believe we can manage 9 or 10 billion people on this planet if we grasp the fact that we have to deal with poverty, if we grasp the fact that we have a system that allows billionaires to put their money away in safe havens where they pay no tax, where you have large companies. We have Starbucks in this country paying very, very little tax because they find ways of getting around it. So what we have is a system creating multi-billionaires and we have a system creating massive poverty. That's not the way forward. We also have a system based on increased productivity through increased consumption. That's not the way forward either. Those are the problems we have to tackle. Now, I think, yes, we have to stop carbon dioxide emissions, we have to deal with methane emissions. Remember what I said about the permafrost, that's a major challenge. But we also have to deal with the fact that we have developed an economic system which has been very successful in spreading wealth around the world, but has been very unsuccessful in the way in which we have damaged the very nest we're trying to live in.
That's great. Thank you.
Thank you.
We're going to do a quick sound